Hello and welcome back. We're at a news conference where we made this announcement about the series in statistics. Today's topic is the significance of the standard deviation. Let's begin. This presentation 3.3, and we want to note the development team of Brad, Spencer, and Amanda. Now, to illustrate these notions, we're using a data set consisting of 6 data items. You see them on the screen here. These may be the ages of persons involved in accidents, perhaps. We want to look at the interpretation meaning of the mean or average. The summation of the x values is the summation of these 6 numbers, 36. The average is the total over the sample size n, 36 over 6, or 6. And we're going to look at the graph of that. Here are the data points. Note on the x-axis we have the record number, and the data points are coming on the screen here. Note that the vertical axis, the sample mean x bar is 6. It's the average, and we're looking at the deviations from the mean. So we have 5 is 1 below, 8 is 2 above, and these are considered to be the positive aspects of the deviations. And you can see the deviations above the line correspond to the deviations below the line, and that's the notion of the mean or average. Now we're going to extend this graph to the notion of a standard deviation, and we're looking at these deviations here. We put in the signed number now. 5 is minus 1 below the mean, 8 is 2 above, and you can see them coming on the screen here. And all the way down to 11, which is 5 above the mean. And we're going to look at the total deviations as 0. That will always be the case. Deviations above the mean counteract those below the mean. Now we're going to look at the standard deviation. We're going to look at this summation here. This is the deviation squared. Here are the deviations. We're simply going to square these, so they're coming on the screen here now. And we're going to ask that you just observe that these squares are almost effectively the areas of squares about the deviations. You see them coming on the screen here now. 2 squared is 4, 3 squared is 9, 1 squared is 1, and so on. And the total deviation squared is 56, and that's the numerator in this expression. Now we're dividing by n minus 1, so effectively we're averaging them out. We're saying the total deviation squared is 56, where normally we divide by 6. But we're going to divide by 5 here for reasons which we'll talk about a little later. 56 over 5, 11.2, and the standard deviation is the side of that square. And this becomes the standard of the error, the standard of the deviation rather. And for population, we divide by n, in which case we divide by 6 here, if this was the entire data set involved. Now we just want to review the formula for the standard deviation. For the population of size n, the standard deviation is the deviation squared as a summation divided by n, and the square root of that. For the sample, we simply divide by n minus 1. It was just found that by dividing by n minus 1, this gives a better estimate of sigma, the population standard deviation. And we're going to look at the empirical rule. We put some values in here. Here's how it happens. If mu is the mean of a population, which is normally distributed, standard deviation sigma. If we go 1 standard deviation either side of the mean, roughly 60% of the data will fall. Within 2 standard deviations, 95%, and within 3 standard deviations, 99.7. And we're looking at this as a concept of probability as area. We're going to discuss that shortly. The probability of finding an x value between a and b here is the area under the curve here, which we suggest is 13.5%. Now we're going to use some specific values here. If the mean mu is 70 and sigma is 10, then we can pace off here in units of tens. Between 60 and 80, 60% of the data will fall. between 50 and 90, 95% will fall. Between 40 and 100, 99%. 99.7% of the data will fall. And so we have probabilities area, the probability of X randomly selected being less than 70 is the area to the left of the center line, which is 50%. The probability of getting a value between 50 and 70 is simply adding up the 13.5 and 34 and to give us 47.5. Between 40 and 80 is a summation of these values here, which is 84%. And that's the end of presentation 3.3. We ask you to review once again, take notes as required, and go to presentation 3.4.